This is ratio percent review in your math journal. It will take up 2 pages. Okay, let's remind you what a ratio is. A ratio compares 2 units, or 2 quantities, we should say, by division. There are 3 ways to write a ratio. We can have A, the word 2, B. We can have A divided by B, or A colon B. So let's say we have a statement. For every 5 girls, there are 3 boys. We would write that as 5, 2, 3. We could write that as 5 over 3, or we could write it as 5 colon 3. Now this is important. If I'm doing girls to boys, the first one always has to be the girls, the second one the boys. So order matters. Okay, sometimes we can reduce ratios. So if I say there are 21 dogs to 30 cats at the shelter, if I'm doing dogs to cats, 21 to 30 is the same as what goes into both 21 and 30? 3. I could rewrite that as 7 to 10. So in other words, for every 7 dogs, there are 10 cats. So this would be the reduced ratio. Or the ratio in its simplest form. Okay, we could do it with the fraction or this one as well. I just chose to write it with the word 2. Okay, sometimes we use tables to compare 2 units. So, if we're talking about equivalent ratios, let's look at other equivalent ratios we could have with our boys and girls. So if I'm using this information up here, I'm comparing girls to boys. So if I have 5 girls for every 3 boys, how many girls would I have if I were 6 boys? Well, this is 2 times this, so I could times this by 2 and there would be 10 girls. If I have 15 girls, there would be 9 boys. So if I look at my original simplified ratio, sometimes it might jump. What if I had 50? What if I had 21? And what if we had 300? Okay, so looking at this, if I'm trying to fill in these, what did I have to do to my original 5? So if I have to have 5 girls for every 3 boys, 5 times what gives me 50? That would be 10 times larger than the original ratio. So this would be 10 times larger than the original. So this would be 30. Okay, 21 is times by 7. So 5 times 7 would be 35. Okay, if I have 300 girls, that would be times 60. So if I do 3 times 60, that would be 180 boys to keep the same ratio. So notice they're all just equivalent fractions throughout that whole thing. Okay. Now this one is going to be a huge one, a unit rate. Unit rate. Let's write the definition first. It's the amount of one quantity of one, actually let's say unit, compared to exactly one of another unit. Okay, that just says unit. A unit rate, the amount of one unit compared to exactly one of another unit. Maybe we, instead of one here, let's write a unit, because this is usually when you're comparing like miles to gallons or dollars to pounds. You're comparing two different units, but I want exactly one. So I want you to put the word per right here in parentheses. Per is a big clue. So if I'm looking at that, let's do an example. It costs $3.42 for 3 pounds of apples. What is the unit rate of price per apple? Okay, this is key. I want to know how much money per, oh, not per apple, per pound of apples. So this is going to be per pound. So I'm taking this and I'm dividing it by this. So I have $3.42 to 3 pounds. Well, I want 1 pound. So what do I need to do to 3 to make it 1? I'm going to divide by 3. So what am I going to do here? I have to divide this by 3. So if I divide $3.42 by 3, 3 goes into 3 one time. Minus 3 gives me 0. Bring down the 4. 3 goes into 4 one time. Don't forget your decimal. Minus 3 gives me 2. Oh, minus 3 gives me 1. Bring down the 2. 3 goes into 12 4 times. So it costs $1.14 per pound. There's my price per pound. Money per pound. So I divided by the number of pounds. Let's do one more example of that. George can travel 365 miles on 15 gallons of gas. What is his miles per gallon? In other words, how far can he travel for 1 gallon of gas? So we're comparing 365 miles to 15 gallons of gas. Miles per gallon, I want for 1 gallon. So if I want for 1 gallon, this means I've got to divide this by 15. So I have to divide this by 15 as well. Okay, to save time and space, I'm going to do it on a calculator just for time. So I'm going to divide 365 by 15. When I do that, I get 24.33333. So 24.3 repeating. So in other words, I get about 24 miles per 1 gallon of gas. Okay, that's a unit rate for exactly 1. And it has everything to do with this first, then this. Miles per gallon, we took the miles and we divided it by the gallons. Okay, go ahead and go to the next page. Okay, I want to use as much space as possible, so I'm going to write up here. Okay, sometimes we might know if, I want you to write down this, if it takes 5 hours to make 7 necklaces, how long would it take to make 30 necklaces? Okay, we have a ratio here. We're comparing hours to necklaces. So if I compare hours to necklaces, it would be 5 hours for 7 necklaces. Well, that's got to be equal to the ratio over here. Now, 7, I'm going to put 30 necklaces because that's what I'm looking for. So we filled in what we know. We know the amount of necklaces. Those have to be equal to each other. Necklaces on the bottom, we're going to have necklaces here. So this would be hours. This is what we call a proportion. So what I'm going to do is I'm going to multiply these and then divide by this to see what I get. And it's going to be a fraction. So I'm going to do 5 times 30, and that's going to equal, I'm going to call this x for now. 5 times 30 equals 7 times x. Well, 5 times 30 is 150. And then if I want to get x by itself, I'm going to divide by 7. Okay, 150 divided by 7, we can have a fraction of an hour or a decimal. So 150 divided by 7 is going to give me 21.4. X equals about 21.4. So it's going to take about 21.4 hours to make 30 necklaces. See, we're using our ratios set equal to each other to figure that out. Now that's going to help us when we deal with percents. Okay, percent. Percent is a ratio that compares to 100. So we can take anything and we're just going to say it's like we have 100 pieces. A ratio that compares to 100. So 7% means 7 parts out of 100. 132% means 132 pieces out of 100. Okay, we need to be able to go from a percent to a decimal to a fraction and back again. So we're going to look at practicing that. Okay, you'll remember me talking about percent man. When he puts on his percent suit, he seems so much bigger. If I were to write 7 over 100 as a decimal, that's going to be 7 hundredths. This would be 132. So we got 32 hundredths and the 1 whole. Okay, these ones are easy to see. Sometimes it's not as easy. But if we're going from decimal to percent, we just move the decimal. So let's do a couple practice here. So decimal to percent. If I have 0.273, that's my decimal. If I want to make it a percent, I'm moving it up so that it seems 100 times bigger. So I'm going to move the decimal 2 places, and that would be equal to 27. See where my decimal is? I moved it 2. 27.3%. If I have 200, that's not what I meant, 2.008, then I'm going to move the decimal 2 times. This is the decimal. Remember, decimal man's like the he's alter ego. We try to look and blend in. Percent man, we're going to move it 2 times to the left, to the right I mean, so it'd be 200.8%. Okay, so if we want to go percent to decimal, if I have 72% and I want to downsize him to decimal, he's weak, and remember, percent man is weak and bold, decimal man is weak and old. Sorry, strong and bold, weak and old. So I'm going to move the decimal back 2 places, and that would be 0.72. Or if I had 0.9% and I turn that into a decimal, I'm going to move it back 2 places. That would be 0.009 because I'm going to move it back 2 places from here. Okay, decimal to percent is easy. Now, just a reminder, if you have a fraction, how can you turn a fraction into a percentage? Well, you know how to turn a fraction into a decimal by dividing. So if I want to go fraction to percent, if I want to go fraction to percent, let's say I have 2/5. If I can turn 2/5 into a decimal, 2 goes inside the box, 5 goes outside the box, 5 goes into 2 0 times, minus 0 gives me 2, annex a decimal and bring down the 0. 5 goes into 24 times. So I went from 2/5, now I've got 0.4, there's the decimal. Now that's easy for me to turn into a percent. Move the decimal 2 times. My answer would be 40%. So 2/5 is equal to 0.4 or 40%. Let's try one more. I might have enough space right here. Here, let's box this off so it doesn't get mixed in. So let's do 1 and 1/8. Okay, if I do 1 1/8, I'm going to turn this into a division problem. So I'm going to make this is the same as 9 over 8. So 9 divided by 8. 8 goes into 9 one time, minus 8 leaves me with 1. Decimal point, annex is 0, bring it down. 8 goes into 10 one time, minus 8 leaves me with 2. 8 goes into, oh, gotta bring down another 0. 8 goes into 20 2 times, minus 16 leaves me with 4. And 8 goes into 45 times. So 1 1/8 is equal to 1.125. There's a decimal. So if I'm going to turn that into a percentage, I'm going to move the decimal back 2 places. That would be 112.5%. Now that means more than 100. So this would be more than 1 whole because it's more than 100%. Alright, last part. Draw a line there. You should have about 1/3 of a page left. We've got to squish some stuff on here. I want you to memorize this if you haven't already. Part over whole equals percent out of 100. I made you say that over and over and over again. Memorize it. It will save your bacon on most percent problems. So, example, what is 15% of 70? Okay, what is 15% of 70? Of is my clue for whole. So right over here next to of, or whole, I want you to write of. Is your clue word for part. So what is 15% of 70? I know the percent, and it's always over 100. 70 is the whole. I'm trying to figure out the part that is 15%. So I'm going to call it X. Okay, this is where we did what we call cross multiplication. So I do 70 times 15. And that's going to equal X times 100. Well, 70 times 15, to save space, I'm going to use a calculator and a little time. 70 times 15 equals 1,050. And now I have X times 100. So I'm going to divide by 100 to undo that timesing. Divide this by 100. So remember, these two have a party and this guy gets mad and divides it up. When I divide by 100, it makes it easy. I'm just going to move back the decimal. So my answer would be X equals 10.5. When I move back that decimal twice, I get 10.5. So 15% of 70 is 10.5. Now, let's do a story problem associated with that. The original price of a, what do we want to buy? The original price of a, let's say, computer is $350. The sale price is $280. What percent of the original price is the sale price? Okay, We have a story problem. This is where you got to pick out things. We're still comparing part to whole equals percent out of 100. So is the sale price the part or the whole? The sale price is part of the original price. So the original price is the whole. So we're going to put 280 up here over 350. Part and whole. And I'm trying to figure out what percent. I'm looking for the percentage. So what percent, I don't know the percent, out of 100. So if I'm looking for the percent that is the original price, what percent is this compared to this? So this is the part, this is the whole. Whole percentage, whole price. Part, part. So 280 times 100 would be 28,000. So I did this times that. And that's going to equal 350 times x. So to undo that, I'm going to divide by 350. Divide by 350. Just because we are short on space. 28,000 divided by 350 equals 80. So I get 80 equals x. X represented this. So if x equals 80, that means the answer is it is 80%, because that's what it asked, of the original price. That means 20% has been discounted. Because 80% is what's left, that means they took 20% off. 20% has been discounted. Means taken off. Sometimes they might ask you what the discount is. I want you to be able to think about that. 20 plus 80 equals 100%.